Today we're doing problem 269 alien dictionary. So there is a new alien language that uses English alphabet. However, we do not know the orders of the letters. We are given list of words in that alphabet, and it is claimed that they are sorted lexicographically. Now, if yes, we return the alphabet, and if not, we return empty string. Now, my thinking is that because lexicographic works by comparing first letter, then second letter, and third letter. So what we get is we know essentially if we got the W here, we know it's in front of this. And if we got W here, we know it's in front of this, and E in front of this, and this, right? So this is the first thing. And essentially we just do this for each word. We compare with each word. Now each word has a length of 100 and there is 100 of them. So for 100 words we go through the entire word and check every other word if it has that many positions, meaning we get 100 cubed, which fits in time complexity. Now what this tells us means that, for example, W has to go before E and W has to go before R. So some of you might already suspect we get a graph. And now if it's truly direct acyclic graph, if it's not, then there is no solution, and if it is, we just do topological sort of the letters, and that's it. So we do like math is this should be K is 26, right? Let's do it like that so that people notice, right? And then for range, let's do W len words for position in range len vi for j in range I plus 1 w if p is less than len vj, and then we want to do vertex 1 is equal to ort of vi or of vip minus ort of a, and then continue, and then v2 ort of vi vjp minus ort of a, and now matrix v1 v2 1, right? So we got that. So we build that adjacency matrix. Now we check for cycle. This v1 parent for u in range k if h vu, and so if not h vu, continue if this u if not this u, DFS UV. If not, so this means that we return true or false if there is a cycle. Has cycle equals DFS for V in range K. If not, this V has cycle or a DFS V minus 1. Right, if has cycle, return this. Otherwise, we want the top sort, which we can do like this. So Q is actually top sort, right? Then we want to do like top sort append V, return join top sort V plus char. No, that's like no, because this gives me or the ordinary, so I want like char of ord A plus V, maybe. I'm not sure what I'm even doing. What's happening here, bruh? What's happening here, bruh? Oof. Oh. Okay. Okay, I'm just doing whatever now. It should be called matrix, right? Now this char ord doesn't make sense, so only can concatenate string, not int to string. So this is int, right? Ord A plus V, I think. Like that. Let's see. ABC, what the hell? Oh, okay. Present. Present V1 true. Interesting. Okay. So view and parent, so why is words JP if v1 so maybe like that. Could use some numpy to get sums over rows, but essentially, okay, so index and then index v2 if any, so that means that it's if all, and this is like x over 0 for x in index, return this, right? Otherwise, if it's not visited and present and in degree of vertex is 0, then we start from there. We cannot access top sort. Great. Awesome. Char ord not sure what's quite wrong, so char or this is such a pain to write every time, so we do all that crap. $17, $19, it's like this. Yeah, we should do like a ID to it. I don't know, like counter ID vertex counter plus equals 1 non-local counter. If visu and IDU IDV, right? ID like that, counter starts at 1. That's the whole shtick, right? Print VU IDV IDU. What the hell? So we start at W, then we go here, where'd you get that from? I mean, this is T, this is T, right? And what does T? So T and F. So T should be in front of F. Oh, because oh. Oh, I'm doing something very wrong. Words I. Words J, I think. Len, right? So we go for these. This is vertex 1. Word A, right? Then we go to present. Okay. Now it's reversed. Okay. Okay. Maybe now we are not printing anything. Yeah. Okay, this should pass. Or no, maybe not. Something wrong. I mean, I understand that you visit B before D, and what does A have to do with that? For char in words I present port A. Okay. is that? So A is over B, I agree with that. And then C is over B, I agree with that, and that's the whole shtick we got, right? So first I visit AB. So essentially we are going to do Kant's algorithm because that is absolute rubbish. If index v0 q append vertex q, so we got a dq, right? And then while q right, then we need like some sort of counter vq pop left idv. Okay, so essentially we number them, and then if we can go there, then we check this, right? So if id of u is smaller than id of v, then we return because there is cycle, right? Top sort up band vertex, right? That's interesting. And then we remove this part because that is crap extreme. And then okay, so then in degree of u minus equals 1, and then we do if in, then we do like q append u, and please just work because this flipping task is crazy. Sequence item 0 expecting instructions found int what? What's up with this, bruh? Like this. Okay, now it makes sense. Still doesn't make sense. Char lead plus ort a. Print view. Okay, so both. Let's see. Okay, so maybe now multi-edges are making a fuss, so and not v1, v2. Okay, we almost got it, except this one didn't work fully. So from V to E, right? E to R, then R to T. What the hell? Just print me V, bro. Okay, and then print VU. Let's see, so from 17, okay. What is that? Why? How? How is that possible, bro? So my problem is at the end that it says that 17.5 in degrees too, and 17.5 in degrees really only one. Let's look at the in degrees. What's the bug? I don't know, I'm not sure. Why is it still 2? Why it's 2, bruv? Well, 19 and 17, right? So from 19 to 5, there is two things, so to 19, so 17 and 5. Wait, there is a cycle, so T before F, and then you say there is a cycle, so no. Oh my god. If like that, okay, then I was double counting. That's crazy. This is printing, this is printing, this is printing, this is printing. There is no way, bro. This gets even worse. What do you mean, bro? What is that? Oh. So you break, right? And now print B. B0. If PLN and when less than len words I, like this. Yep. Okay, let's submit again. If len tops or don't equal sum. Okay. Maybe my whatever is not the best, but who cares? No way, finally. It's the slowest, but who cares? I guess. So only thing is that, let's call it like x is this, and now if not, then total present is 0, and then in laptop so doesn't total can actually return way sooner than that. Zero index 0. Okay, so that means that if index equals 0, 0, index plus equals 1, and then 0 index. I have to do this at the end, okay. Oof, sucks. if I want to do that, if so there is, so we subtract some parts, and now if okay, what does that mean, bruv? So that's not that. If not present x, then total present plus equals 1. If not present, you know what, let's do this, right? And then let's see if this will work. Okay, we are still at 4 milliseconds, presumably because of this. I'm doing a lots of translations, so if I do like for I in range W, for J in range line words I, words I is equal to list map, and now this is like so this is a lambda function. Okay, that's fair. And finally, we don't have to do this. Or A is 97, okay. might work. No. What was that? Okay. Still don't work, but that's fine. Positive index. If index beta 0. Right, and now if pos index is equal to maybe like that. What? Okay, who cares? 42 minutes, are you kidding me? That is ridiculous for a task I knew how to solve in few minutes. Okay. Topological sort, and now what do we do? That's like, let's say we have number of words and length, so I would say m squared plus k. Okay, so since let's assume the words are sorted lexicographically, then we compare each pair of words and find first non-matching character by character and find the first non-matching position. Pair let the letter from earlier word be char1 and letter from later word be char2. We know char1 has to come before char2. No, we know that char2 has to come after char1 in the alphabet ordering. Some of you might already suspect what is going on. We create these after relationships are directed edges in a graph with nodes being the letters of the alphabet. The ordering, if there is a cycle in this graph, there is no valid ordering, otherwise we can find it with a topological sort. using approach. Note that if prefixes of a pair of words, if all prefixes of pair of words are equal, but the first word is longer, there is no ordering since by lexicographic ordering this should not happen. We can use Kahn's algorithm, which puts all nodes with degree 0 into a queue until it's not empty. For each node W, we check its neighbors, and yeah, these IDs I can skip, to be honest. If we subtract 1 from in degree of the neighbors and of the neighbor becomes 0, we add it to the queue. Note that to detect the cycles, we assign IDs to the nodes based on the order we visit them, and if the neighbor has an ID smaller than the current node, we know there is a cycle. O of nm squared plus k is the number of the words, m is the maximum length of all the words, and k is the size of the alphabet, since we compare n squared m like that. Okay. Since we first compare all pairs of all n squared pairs of words and iterate over them in m, and then run a topological sort on the another note. If our topological sort algorithm did not visit all letters present in all nodes letters in the graph, i.e. length of visited doesn't equal number of nodes, we also return we know there is cycle where since each node inside of it has a positive in degree, so we never visit it. Okay, so back to here, so and then run a topological sort on the graph of k nodes, which takes O of v plus e, where v is the number of vertices. And I mean, technically, could there be k squared? I mean, there could be. So this is k squared, because technically we could. There is what? Yeah. So where v is number of. Could that be though? Of the edges of the graph, which is OK squared in our case, in worst case. What's the memory? K squared, I think. I mean, no. So I just use matrix and bunch of OKs. Okay, since we store the matrix, since there is at most k squared edges in the graph, so either implementation is so adjacency list, so both matrix take up the same worst case space, have the same worst case space complexity, and then we have a bunch of OK arrays for visited for holding extra information about the nodes. Okay, so absolutely pointless write-up, because nobody is ever gonna read this since I will not publish it, so goodbye.